AMJAD, what you doing?
Hey, I've been thinking, how do I actually calculate nasi lemak, fried rice, and also fried noodle that we can cook within a specific time frame, and how actually we calculate it using matrices. And I also want to ask you about how many matrices are there. Actually, I have done some research, but I actually don't get it.
Okay, so like you said, we can calculate it using matrices, but there are two methods of calculation, either using inverse method or Cramer rules. But first, you said that you need to know the time needed allocated to cook the nasi lemak, fried rice, and mee goreng, right? So I suggest that you get me all the necessary data first.
Okay.
How about you go to AQIL and ask him about all of the information needed, since I think he's told me he used to work in F&B store.
Oh, okay. Okay.
Yes.
Since you work at F&B store, can you give me some information about my placing here?
Oh, okay. From what I'm understanding from your question, you are trying to create a time for each menu at each stage, right? Okay. To get the correct data with the real-time experience from my past experience, we need to look at first at the actual operation of each stage. For example, during the prepping stage, nasi lemak, as we know, has many side dish like anchovies and spinach. So we need to allocate more time. For example, maybe 2 minutes for nasi lemak, so we can prepare for it first. And for fried rice and mee goreng, they only take 1 minute for each portion during prepping stage. And next, we look at the cooking stage. During cooking stage, fried rice is take more time for cook. Why? Because to cook a fried rice, we need to heat it with high heat temperature, so the rice doesn't clump together. And unlike other food like nasi lemak and mee goreng, they only take about 1 minute for each menu. Finally, for packing stage, I think that we need to allocate 2 minutes for each portion of mee goreng, because mee goreng is quite stringy, right? For the packaging is quite hard, so we need to allocate 2 minutes. Unlike other menu like nasi lemak and fried rice, we need to allocate only 1 minute. I think it's suitable for our task. Do you have any other question?
No, okay, thank you. I will return to Alif. Alif.
Yes.
I already get the information and data. Can you help me with the calculation?
Okay, AMJAD, you have got me the data from AQIL. The data that he gave is the time allocated for each station, which are prepping station, cooking station, and also packing station. Now, with that in mind, we need to set all the variables that are needed for our calculation. So we will use variable A, B, and C. Variable A is referring to the nasi lemak, B is referring to fried rice, while C is referring to mee goreng portions. So what do we do now? We need to form the three equations needed. So the equation we form is 2A plus B plus C equals to 90. A plus 3B plus 2C equals to 150. A plus B plus 2C equals to 90. From these three equations, we can turn it into matrices form that consist of three matrices. The elements in the first matrices is 2, 1, 1, 1, 3, 2, 1, 1, 2. The second matrices consists of A, B, and C, where they only fill in the first column, and the last one is 90, 150, and 90. The first matrices we refer it to as A, Now we need to find the determinant. So how to find a determinant? Determinant is determined using the formula A11 times M11 minus A12 times M12 plus A13 times M13. A11 is referring to the element in the first row and the first column, while all the M's, for example M11, are matrices that are formed while not taking the numbers that are in the same row or column as A11. So as you see here, the matrices that we form from M11 is 3, 2, 1 and 2. We do not take the ones and 1 in the same row as number 2 and 1 and 1 from the same column as number 2. Do it for the whole equation. So you will get 2 times matrices 3, 2, 1, 2 minus 1 times 1, 2, 1, 2 plus 1 in matrices 1, 3, 1, 1. Okay, I want you to take a look in the symbol. The first symbol is positive, next one is negative, and it will revert back to positive again. Keep that in mind, okay? It will be useful later. Now, what do? We need to change the matrices form into AD minus BC. The A is the top right, the top left element in the top left. B is the one next to it. C is 1 and the D is 2. So once you do it to all the other matrices, you will get 2 in the column. 3 times 2 minus 2 times 1 minus 1 in the bracket. 1 times 2 minus 2 times 1 plus 1 in the bracket. 1 times 1, 3 times 1. Once you expand it, the determinant we will obtain is 6. Now we need to find the cofactor. The cofactor consists of matrices that consist of 9 other matrices. What are the 9 matrices? It is M11, M12, M13, M21, M22, M23, M31, M32, M33. So like I said just now, the M's, the M's are matrices that do not take the numbers from the coordinate, that don't take the numbers from the same row and the same column from the element in the coordinate. So like I said just now, M1 element is in M11 is 2. The numbers that are in the same row and column as 2 is 1 and 1, 1 and 1. So the matrices that are excluded from the same row and the same column is 3, 2, 1 and 2. So the whole matrices you will get from the whole 9 matrices you will obtain is 3, 2, 1, 2, 1, 2, 1, 2, 1, 3, 1, 1. That's the first 3. You do it. You found it just now when trying to looking for the determinant. Next one is 1, 1, 1, 2, 2, 1, 1, 2, 2, 1, 1, 1, 1, 1, 3, 2, 2, 1, 1, 2, and the last matrices is consist of element 2, 1, 1, 3. Now remember that I said you need to take a look and pay close attention to the symbol, plus, minus, and positive again, because you need to remember the pattern. For the first one is positive, and the next one will be negative and positive again. So here, the first one is positive, next one is negative. After that, it will become positive again. Do it until the final matrices. So the third one will hold positive. So the fourth one will be negative, positive, and negative again. Positive, negative, and positive again. Like determinant, the M's you need to substitute it in the equation AD minus BC. So once you have expand and calculate it, you will find the matrices 4, 0, -2, -1, 3, -1, -1, -3, and 5. Now we need to find the adjoint of matrices A. How do we adjoin the matrices? We need to transpose the cofactors that we found just now. Okay. There are rules to transpose. The first one that I really like is, see this diagonal number, the number in the diagonal centerpiece. This is 4, 3, and 5. When you're transposing a matrices, the number in the diagonal won't change. Okay, that's a rule that you need to remember, okay? Now, what are transpose? Transpose are where the number in the column is substitute into the row, while the number in the row is substituted into the column. So the cofactor we got just now is 4, 0, -2, -1, 3, -1, -1, -3, and 5, right? So what I mean by the place switching up is 0 and -2 will go down here, and -1 and -1 will go up here, and you will get 4, -1, -1, 4, 0, -2. Do it for the others as well. For number 3, numbers in its row is 0 and -3, while number in its column is -1 and -1. 0. Thus, when you change the position, the one that will fill the column is -1 and -1, while number in the row is 0 and -3. So the whole matrices that you'll get is 4, -1, -1, 0, 3, -3, -2, -1, and 5. That's the adjoint A. For the final step, we need to insert it in the equation. A inverse equals to X equals to A inverse B. A inverse is referring to 1 over determinant times adjoint A. Okay. So you already gotten the adjoint A. We already got our determinant. Now we need to substitute them into the equation. Okay, X, the variable, equals to 1 over 6. The determinant and adjoint A. Adjoint A is 4, -1, -1, 0, 3, -3, -2, -1, and 5. And B is referring to the time allocated, which are 90, 150, and 90. I suggest that you handle the matrices first. So you need to multiply these two matrices, and once you calculate it and expand it, you will obtain the matrices 120, 180, and 120. But our calculation is not yet completed because there are still 1 over 6 here. So when you multiply it into the matrices, you will obtain 20, 30, and 20. So what this means that for this period, 20 nasi lemak portion is prepared, 30 fried rice portions are prepared, and 20 mee goreng portions are prepared. Okay, do you understand them, Amjad?
Oh, like that. Okay, thank you, Arif.
Now you know how to do inverse method for matrices.
Okay.